Hello, welcome to Calculus Online at BMCC. My name is Gary Parker. I'll be teaching the course this quarter. So you can't come to a regular class, you take it online. It's great. I have a whole bunch of resources for you. So we're going to take a look at the Myopenmath course. So I'm going to share my screen with you. So the view you have of the course in Myopenmath should look something like this right now. Eventually there'll be other stuff down here, but we switched to a new book this term, and so I'm still working on those materials. So I'm almost done with chapter 3. Got a couple more sections to finish up, and then I got to finish up chapter 4. And what I'm doing is just finding videos for those of you that are online, in addition to making some, and then making sure the problem sets are reasonable depending on the topic in the book. So chapters 3 and 4 will be available soon. For now, you've got the course information section. If you're online, I would like to meet you soon. So if you can't come to the Pendleton campus, that means you need to do a video chat with me, and I use Google Hangouts, which can also work with YouTube Live. I scheduled some times here. I've met a couple of you online so far, but there's a few more people I need to meet. So please check out one of these times and then log in to meet me. Each time I do a chat, I will post the new link to it here. Alternatively, if you check out, let's see, if we click on online video chat here, you can go to my Google Plus homepage, and every time I do a chat, it will appear on this page. Let's say we're satisfied with Google today. Oh, please go away. All right, so right here you see that live one here was the one from 11 o'clock today. And I have some others scheduled here. Let's see, these past ones. Yeah, so there's the announcement that I'm going to do it, and then there's a link to view it, and there's a link to join it. So this is the 4 p.m. one. You would click sign in with Google here. And it'll ask you for your Google account if you're not already signed in, and that'll get you there. So hopefully you'll meet me online soon. Back to the course here, some other useful information on this page. Here's a link to the textbook. Once you're in there, you can view the book online. They have a nice web view of the book. I use this often when I have an internet connection. And you can pick which section you want. Like we're starting off in chapter 2. Today we worked on a preview of calculus at 11 a.m. And then there's a PDF that you can download. Put it on your phone, put it on your computer, put it on your favorite device so that you can access it when you're offline. I like the PDF view more often than I think the web book, but they're both good. Intro to Myopenmath, whether you've used it or not before, please check this assignment out. It says it's expired. Bizarro. I'll fix that. There's a calculus forum where you can ask questions, student solutions manual based on problems in the textbook, not the online homework, the syllabus, which you should read. And if you're having technical issues with Google Hangouts, which is different from getting to Google Hangouts, this page offers some more information. I recommend using Google Chrome because then the connection's easier. Firefox is the next best. I don't recommend Internet Explorer at all, and Edge should work okay if you get the right plugin. Chapter 1, this is our review. It is totally optional. You can choose to do this stuff or not. This is a section of an Intro to Calculus book that our current book was based on. I like it, so I posted it there. Highly recommend you take a look at what this author had to say about the Intro to Calculus. Optional sample problems here. You don't have to do them. And moving on. Chapter 2 is where we really begin. So each section is set up pretty much the same way. There's a link to the online textbook. It takes you to the specific section that we're focusing on at that moment. These are the learning outcomes. So if you don't feel motivated enough to read the book, at least read what we're going to do. Videos, if you're not coming to class. And then over here, you have the actual homework. Each problem, when you do the homework, has, when you click in a spot, says, hey, this is how you should enter your answer, more information if you need it. And sometimes if you click the yellow box, it gives you other ways to do stuff. I'll jump over to problem 3 because it's a cute one. So problem 3 says we have some point 211. It lies on the curve y equals x squared plus x plus 5. And point Q is some other point on that curve. What we want to do is find the secant line. And a secant line is just a line connecting through 2 points. Those 2 points lie on some other curve. So for example, if you take a look at problem 2 here, that is a secant line connecting these 2 points on the curve. So we're going to create some more secant lines here. Good places to do this. The Desmos graphing calculator is lovely. I'm going to do this in a spreadsheet. So my point x equals 2, my function x squared plus x plus 5. So spreadsheet, good idea to label your spreadsheet. I'm on problem number 3. I put a B there because this is my second attempt at it, just for fun. And I'm going to label a column for x's. I'm going to label a column for y's. Make a note y equals x squared plus x plus 5. And then here, if I type 2, I'll do the calculation equals 2 squared plus 2 plus 5. And instead of typing 2, I'm just saying, hey, use the cell where 2 lives. Because if the problem says, yeah, use x equals 5, I just put a 5 there, and the computer automatically updates the y value there. Blow that up a little more, put that 2 back in. Next thing I want to do is I want to get another point. So they say, next, we want you to use, let's see, 2.1, 2.01, 1.9, 1.99. So I got to check that out. So I want to try x equals 2.1. Once I've typed the formula for y with cell references, I can just use this magic button here to fill it down. So now I know the next one. What I want to do here is find the slope through those 2 points, so I can make a slope column next. And for my slope, that's going to be equal to change in y, parentheses. So this number minus that y value, close parentheses, divided by change in x. So same order, this x value minus this x value. And then I hit enter, it says 5.1. I can put a 5.1 in here. If I'm clever with a spreadsheet, I can do, I don't want to submit yet. I can do all of these at once. Hitting enter on the keyboard on a multi-part problem means you submitted the whole thing, so be careful about that. Just almost messed that up. And by the way, I keep checking this, hoping someone's going to join me live here, but it looks like it's just me today. Oh well. It's more fun to do math with other people, but sometimes it's fun to do it alone. Other numbers 2.01, filling this down will give me the y. Now filling this down is going to cause trouble, because the way this formula worked is it found the point, there's a point to the left and there's a point above and to the left. And when I fill it down, what it's going to do is it's going to find the slope between these two instead, which isn't what I want. So I'm going to modify this formula by telling it to, for the second point, always look in row 2. So to do that, B2, I put a $sign in front of the 2 saying don't screw with row 2. And then here for A2, put a $sign saying don't screw with row 2 there. What that'll do is it'll allow the, when I go to find the slope, it'll say always use this row to get the second point, and then use whatever rows to the left to get the first point. So now if I fill that down, it should work correctly, and see it's grabbing the correct stuff. So I can even go in here and plug in my other numbers like 1.9 and 1.99, and then I can fill down both of these formulas and they'll all work beautifully. So this one right here, notice it's using the correct 2 points. Do you have to use a spreadsheet? No, I just like them. All right, no one there still, just me and you in the future. So there's my answers. And it looks here as I get closer to 2, right? 2.1, 2.01, that's closer to 2. Looks like I'm getting closer to 5, 1.9, 1.99. Y value goes 4.9, 4.999. So I'm guessing that at 2, the slope is about 5, right? Which is kind of a weird idea, because to find the slope, you need 2 points. So the thing is, we're trying to say, well, what would the slope be if we only had 1 point? And we can look at that graphically in a sec. So back to my homework. I can type the other numbers. Oh, there you go. Wait, wrong one. There you go. All right, so we got 5.01, 4.9, 4.99, and then I'm guessing that those numbers are all heading toward 5. There's a video here that guides you through a similar problem. Submit. Woo, it's right. All right, I'm going to do it a slightly different way. Let's take a look at Desmos graphing calculator. And with Desmos, I'm going to enter function notation, f of x. Ooh, f of x equals x squared. With Desmos, you got to arrow out of the square to the right, and then you can go plus x, and then, what's it, plus 5? And the point I'm most interested in is that point 2, comma, and then I can just type f of 2, and it will calculate it for me. And we'll label it. No, come on. All right, sorry, I don't use Desmos much, but I'll get better. 211, there it is, 211. And then I can find the other point, like, let's see, what was that one? 2.1 is where we started, comma, f of 2.1. So there's that other point, and I'm trying to find the line between them. So I'll need to find the slope. We'll call that m1 maybe, and that's going to be equal to f of 2.1. Get my fraction in there, minus f of 2. And if this function notation looks weird, you'll get used to it. That's part of calculus. 2.1 minus 2. So it says the slope there is 5.1. Now all I needed was the slope, but just for fun, I'm going to put that line in there. And so the line, I'm going to use the point slope version of the line, which is y equals the slope, m1, times x minus the x value. Well, I'm using 2 as the key x value. And then you add on the y value there, so f of 2. And that's going to give me a point passing through those 2 points because I'm using this initial point and then the slope between those 2 points. And then I could zoom in there. And what you can see there is the line and the curve kind of coincide there. They only intersect at this point and this point. If we change the scale to widen this a little bit, we'd see that. But I don't want to worry about that right now. I'm going to put another little twist in here. I'm going to type another value a, and let's see, a equals, let's start with 2.1, and I'm going to make it a slider. Go from 1 to, let's say, 3, and we'll step by 0.01 maybe. All right, so then I'm going to replace these guys with a. This is kind of a cute trick. You don't have to know how to do this, but I'm going to show you something cute. See, that's an a, so this should be an a, and this should be an a. All right, so now what I do is I have based on this slider, I have a point that I can move around and see what happens with that slope. So as I've dragged that point farther away, I'm going to see the slope gets further away from 5. If I drag that point toward the other one, I should see it gets closer to 5. And it's having a hard time tracking as we get really close. And if I try to put it right on top, it fails. Why did it fail? That's interesting. Well, what happens right on top is we have f of 2 minus f of 2, which is 0, divided by 2 minus 2, which is 0. So we get 0 divided by 0. And if you ask most calculators, what is 0 divided by 0, it's going to say, hey, that ain't a number. It didn't give me a calculator. Let's do 0 divided by 1. A nice error from a calculator. 0 divided by 0 equals error. Desmos is a calculator, so it says the same thing. 0 divided by 0, undefined. So one of our tricks in calculus is going to be trying to learn how to take these secant lines and turn them into tangent lines. So a secant line is a line through a curve through 2 points. Tangent line is when those 2 points basically come on top of each other, so we get a line at a single point on a curve. And that's a little trickier. So let's turn this off, delete that, and I'll just show you the tangent line. So I'm guessing the slope is 5, right, based on our work. So if I go y equals 5 times x minus 2, and then I add on that 11, because that is the y value of that point, that's the point slope version of a line. And you can see here, zoom out a little bit, that I now have a line, let's turn off that one too, through that original point, 211, that has the same kind of slope as the curve. So, just think about this being a hill you're climbing. At that point, the curve and the line have the same pitch at that point. This is the big idea of Calculus 1, and we're going to spend a bunch of time playing with it. So that's it for now. I just wanted to do a little math, say hello to y'all. Have a good day. Do good math. Bye-bye.